So first thing, what's really ASP.NET Core? Yeah, we know the startup. We know that there is a lot of configuration around. We know that it throws a lot of errors. What's really the thing? Yeah, in my understanding, it has 4 major parts. The first is bootstrapping, which is in general what I just described. It's the startup, the configuration, adding middleware, things like that. It's served by 2 major interfaces. iHosted service, which hosts the service, and it uses iApplication Builder to create a pipeline. Then there is a server context, which is, of course, HTTP context, and the pipeline. So together, the relations are kind of these interfaces, or relations of these interfaces. The most important is the server one, which represents the server. There are 3 implementations now. First is Kestrel, which is the most recommended one for ASP.NET Core and for a standalone server in general. Simply used to use IIS, and http.sys, which is more system part of Windows. It's used for its communication of its components and things like that. And all these 3 implementations are implementations of iServer. So in this iServer, you see features. This is a list of features supported by the server. You see that it can be started and stopped. The interesting part is this iHTTP application. This iHTTP application is what really handles the requests. We will take a closer look on that one. You see that it basically has 3 methods: create context, process the request, and dispose context, which is what basically happens every time it gets a call. Then we see the bootstrapping part, which is again has start and stop. And in iApplication Builder, you see the methods I guess you are the most familiar with. You see application services, which is a good old iService provider, some properties, and the use, where you insert a functor of request delegate, resulting in another request delegate, which is the middleware. So if we start with the hosting application, which is that one that realizes the call, it implements the interface, of course. As you see, it creates HTTP context with the set of features for the server. Then it has a method for processing the request using the pipeline, which is called application here. And then in the very end, it has another method to dispose context. You see that it uses iHTTP context factory for both. And it's related to first conundrum I really had. And we had to somehow solve it when we were working, writing a framework for .NET. And it is, how can I access HTTP context the very first, before any user can access it and do something that I wouldn't be able to handle because I wasn't there at the time? And the second question, how can I access the HTTP context the very last and dispose all the things that I want for users to be there to use? It can't be disposed while they still can use the context. So you see that here is how the context really is created. And you see that if you use the default HTTP context and the default HTTP context factory, it does some pooling. And if not, if you write your own, then it simply creates the context from the very start each time, and then it disposes it. So, you know, because the HTTP context factory is really, let's say, promising, yeah? I would say, you know, it does create a context, it disposes it, so maybe I will write my own implementation, but it's a wrong way because the performance penalty is actually high, because if it's not pooled, it's created over and over and over. There is a lot of streams and other memory parts that need to be allocated again and again, and the overall penalty isn't really worth it. So the first thing I learned from it: don't create your own implementation of IHTTP context factory. Use the default, because they are part of the, let's say, broader ecosystem. So, but if we take a look at the default HTTP context factory, we may notice something that it does here in the HTTP context accessor, or with the HTTP context accessor. And it really feels like that it's something that it does in the very start, right after it's initialized with the features, which is something we don't really have to interfere with. And then, when it's disposed, it nullifies the HTTP context accessor. And if we take a look back, we will see that, oh my, that was forward. So if we take a look back, we see that the hosting application does the very same thing. So someone really wants this to be done, and it's really done in the very start and end of the lifetime of HTTP context. So what we can do, the IHTTP context accessor uses async local. That's how it stores the HTTP context for the current call. And it's just an interface that is in the and can be overridden. So if I take a look, it only does one thing. Yeah, it stores the HTTP context instance into the async local storage. And if it's nullified, it basically nullified the storage. So I can write my own implementation, but you know, maybe I'm not the first who has this idea. There can be like other implementations from users. Would I interfere with their implementations? Not really. It's enough for me to be like late enough, and I can grab the current IHTTP context accessor and wrap it with my own implementation. Then I will just, here is an example, that when I set a value, which is when the HTTP context is just created, I can do some actions, and then I will, of course, use the wrapped context to basically do what the HTTP context accessor needs to be done. So, if we take a look back, we now talked about the server, and about the feature collection, and about the application. And the resting part is the pipeline. But before, let's mention the request delegate. The request delegate is just a delegate. You see that it expects HTTP context, it returns a task, or we may bounce into it as a functor. So it is a func of HTTP context returning another, sorry, there should be a task. Returning the task again. We know that it's built by iApplication Builder, and that it's orchestrated by the iHosted service. So if you remember the hosting application, this request delegate is what you find here. It's called application, and this is actually the pipeline. It's the only thing that actually happens to the HTTP context. This thing only does three things. It creates context, processes with the application, aka request delegate, aka pipeline, and disposes the context because it's done. So, if we take a look into the default application builder, we most likely are familiar with this function, where we add a middleware. You see that it simply adds this functor into something called components. And then when you run build, creating the pipeline, you see that there is some default middleware that will be right at the end of the pipeline. And before it, there will be all the middlewares that you did. You may notice that it's running reverse from the very last to the very first. That's how it basically works. If you add middleware A and middleware B, you really want the middleware A to be created the very last and contain the middleware B, because it will call then the middleware B, then the middleware C, etc., and then it will go the opposite direction back. So this middleware added by .NET actually serves for telling us that we didn't handle the request anyhow, that it simply reached the end of the pipeline, and that's basically it. If there was no endpoint, no routing happened and anything, it simply returns 404, means not found. If there was some routing, but actually no endpoint handled the request, it will show this message that the request reached the end of the pipeline and no endpoint was, or the endpoint mentioned there wasn't executed. So we should register the endpoint middleware. But we had an issue with my service team long ago, before Kentico, because Kentico doesn't have issues, of course. So we had an issue that we got this exception, and we were quite puzzled because honestly the endpoint middleware was pretty much there, and the very endpoint that it should reach was pretty much there in the pipeline. We tried, but still we were getting this error. And the issue actually was that we were using multiple ports. So we had one port for SSL, we had another port for MTLS, which is mutual TLS, and that endpoint was actually meant for the MTLS one, but we kind of misconfigured the ints, because they are all ints, yeah, same int, different values, same int, and that was the issue. When we fixed the port value, it was working like magic. So this message mostly does a great job, but it can't handle all the bad things you can do with your servers. And now we were just talking about the builder, but this builder isn't really hanging in the air. So it's used by this generic host website. The mission of this generic host website is, generic web host service is to manage the bootstrapping process. You see, it basically does that. It creates the builder with the features again. Then it will apply all the startup filters in reverse again, because the same idea basically. And do you know how these two differ? What's different with startup filter to the middleware? So the middleware is executed for each request, yeah? But the startup filter is only executed when the application starts. So it's some preparing, warming up business. So it will do all of that. And then it will call the builder, which will kind of apply the same pattern. And we already saw it. And then when the pipeline is created, it will create a hosting application. That's still the hosting application that we saw that handles the requests themselves. And you see that we'll use the application that we just created, the HTTP context factory, of course, and the logger and couple other things for diagnostics. And then the server starts. So the pipeline consists of middlewares, and the middleware is just encapsulated request delegate. So a little example, we have here something called convention middleware. It's called convention because it simply has a method called invoke, and it's convention that it's called either invoke or invoke async. And that invoke simply does something, and as the part of something, it calls the next step, the next middleware, if there is any. Yeah. Here, this middleware really relies on that the next middleware exists, because if it would be null, we would get a nasty error. So there should be really a question mark and invoke. And the overall idea is that the request comes, then it goes to the very end of the pipeline, or that middleware that simply doesn't call the next one and start the other way back. And here we should have a response sent and everything done. So that example that I provided isn't, really truthful. It did literally nothing. But there is another example that is an example of how simple ASP.NET actually is, and that's how the pipeline can be forked. If you use map on iApplication Builder, the thing that, as we see here, I created the builder, the web application builder, and then I registered a couple of services and called build, which gave me the app builder. And then I call map admin, and as part of this admin, I will handle some admin related requests. And what happens behind the scene is that this map extension method is called, and you may see that it checks that the path ends with a slash. If the path doesn't end with the slash. And if it doesn't, it create a new builder for the branch. It will apply the configuration that I provided for the branch. It will create a pipeline. It's just pipeline like any else. If you would like, you can put it into the host application and you may just run it. And then it saves the pipeline into options as a branch. Yeah. And in the end, it adds the map middleware. So in the main pipeline, I now have this map middleware at some point. And this map middleware only checks if the path starts with the segment I wrote. And if it does, it calls options branch, I mean that sub pipeline, instead of calling the main branch, I mean the main pipeline. Yeah. So if the call starts with admin, this sub branch is called instead of executing or continuing with the main pipeline. So it's just simple. Yeah. It starts with the path. I call this branch and I'm done. Yeah. So we are talking about middlewares, and as you may know, there is a whole bunch of ways how to add a middleware, of how the middleware can be done. And I always wondered how they are in terms of performance. Yeah. Just for comparing, I created a benchmark for a direct call. this is just a call for method. Yeah, if you call a method, it takes 8.8 nanosecond on my machine, of course. And the second one is actually the convention middleware. It uses reflection, and it struck me a bit because, you know, reflection is bad, right? Right. Reflection is wrong. We don't like it. So how it can be so fast? Yeah, I created this this prepare middleware only creates the request delegate for me, but it uses the same logic as application builder use middleware. So if we take on, yes, this is the middleware I used. That's the example. So if you call that use middleware with that convention-based middleware, it will really do the reflection. You see that we have all the methods we all know, but we don't admit it, right? The get methods, it's instant public, and then we check if it's invoke method name or invoke async method name, because you know, it's string, so let's check. And then we check the parameters if they are either none or just HTTP context, and we put the next as the first parameter. There is the magic. We create an array that is one position longer and copy it from position 1, and then we put the request delegate for the next I would say the next middleware as the first one. But there is one thing why it's so fast. There is this innocently looking method call called compile, and this method creates an expression, and then in the very end it will compile the expression. So there is dynamically created method for it, and that's why it's so fast. So the conventional middleware did a great job for us. Honestly, it's even faster than a direct method invocation that I will say, okay, I have request delegate, but I have a method that expects the HTTP context and return task, so I will simply, you know, return the method, and that's it. Yeah, the method info, and we are done. And you see that it's even slower than this compiled expression. So it's a great job, really. Then of course we can use a delegate that we have some functor that expects the HTTP context, the next, and it returns task. And it's about the same performance. There are a couple more indirections and you know, stuff like this, so it's understandable. And then we have like first bigger gap. Yeah, we have 10 nanoseconds and then 18 nanoseconds. And you know what's more? It allocated memory. You know what the daring code it is that it allocated our precious memory, yeah, right? So do you know why it's happening? If we use this lambda, that we actually don't really need the next, we, you know, only get func task, that we don't want to pass the context to the next. We aren't very into passing things. So why it's slower and why it allocates? Yeah, by lambda. Yeah. So you know, it's just a syntactic checker. It will create kind of dummy functor for us, and it will simply feed our middleware with the functor, thinking that it's something special, that it doesn't have to pass the HTTP context, but it really does, because it only bridge it and pass the HTTP context to the very next middleware. So if you don't want to pass HTTP context, still use the delegate option and just ignore just pass whatever comes, because it's faster. Then we have interface middleware. which is that middleware that uses this I middleware interface. And, you know, it took 59.8 nanoseconds. And, you know, interestingly, it's not because I started Teams or something at the same time. It's really, you know, consistently that slow. And do you know why it is so? Because this I middleware actually isn't just a way to, you know, get rid of reflection. Reflection is fine, it's fast. So the idea behind this this middleware, I middleware interface is that we may have a middleware that needs to be disposed. Yeah, and the thing with disposing middleware is that once you create the middleware and it's part of the pipeline, it can't be really disposed, yeah, because the other calls would just, you know, would be just done, right? So what you can do instead is that you, on each request, you use some middleware factory. You get this middleware using the factory. The factory, of course, is a level of indirection to make testing easier and you know, delegate the function. Then you use the middleware, and in the very end you use again the middleware factory to release, aka dispose the middleware. You can do whatever you want, and I guess you want to dispose the middleware if you pay, you know, all that nanoseconds for it. So this is basically why. And you know, what's more, .NET doesn't really want you to shoot your own lag. So this is done in, let's say, very general and robust form, using that middleware factory and calling back for release. So because if you want just to create a new instance of middleware on each request, which is what this Kent interface middleware really does, it only uses 29.2 nanoseconds. So, you know, the moral of this is, if you want to dispose your middleware on each request, don't do it. Yeah. And if you really want, because you create a presentation about it or something, then you would be better with your own implementation of it, because it's basically faster. So this is all. So as the summary, what is really behind this presentation, what I wanted to show is that first, ASP.NET is simple and extensible, because as you saw, all the concepts that we saw are here for us. We could write our own implementation. The code that we saw was like any other C# code that we can write on our own, yeah, except it's already written and tested and battle tested and everything from .NET. So don't really implement it on your own, but basically you can, yeah, if you have very long time. The next is that HTTP context is just an instance of a method stored in some async local storage. It's not, there is nothing special in HTTP context really. That the forking the pipeline is it's just one if. Yeah, there is nothing special in it, no magic. Of course, the conventional middleware is really good, and syntactic sugar really isn't, like, you know, like all the sugar. Yeah. And yeah, the error message may be confusing that if you have multiple ports. And that's it.